Okay, very good. All right, now before you get going, I'm going to introduce you. And my goal in this introduction is to make you blush. So we'll see how successful I am. So Steve Gottlieb, if you don't know, you should know. Um, he is, in my estimation, the preeminent visual observer of our age. Um, he has visually seen and described all NGC objects and most, and maybe all the icy objects by now. We were closing in on them a year ago. And he I alluded to him during my presentation about how he can use words the way I sketch, because his descriptions are so detailed and so good. If you get the Nexus digital setting circles, his descriptions are in as part of that software of that device. So if you bring up the description of an object, that's his description from his observations. He's also a great guy, and I'm lucky to call him a friend. We go out to visit our friend, our mutual friend, Jimmy Lowry in West Texas. Um, Usually at least once a year, sometimes twice. And it's a real treat, a rare treat to be able to do that with people like Steve and Jimmy, who we all get so excited. We're like little kids with that big telescope under a dark West Texas sky. And yeah, if you go to the Golden State Star Party in Northern California, which is usually held in June, you will be able to meet Steve, and he has his 24-inch star structure telescope. Jimmy Lowry is there. Of course, he leaves his 48-inch at home, um, but he's there, and we just have a great time observing the Northern California early summer sky. Um, and so, with no further ado, I don't think that was very embarrassing. I
That was
couldn't think
okay.
of
That
anything
was
embarrassing
okay.
to say. Sorry, Steve. Um, so why don't you take it away? And here we go.
Okay. Is my audio coming okay through?
Okay, I think you're muted.
Okay. Oh,
Oh, it could be an R end. Hold
no.
hold
No,
on.
you're coming through okay.
Okay. You can hear me?
Ooh, the phone.
Yes.
Okay. Can you hear me, Howard?
Yes, we can now.
Okay.
Yeah, yeah, go ahead.
Okay. Well, I think Howard was a little over generous in his introduction, but I'll take it. Um, I think my talk will be a sort of a good bookend to Howard's talk because we have very different approaches, I guess, to amateur astronomy. Howard through telescope making. I've never built a telescope at all. Howard is the consummate sketcher, other than some chicken scratches I sometimes do with the eyepiece. I don't do any sketching at all. But what I've always done from the very beginning is take observing notes. And I've always been very organized in that manner. And I've kept my observing notes, my log books. I'll show you one of them pretty soon, from the very beginning, going back 47 years. And just like Howard has his early sketches, I have all my early notes also. Of course, at one point, when I first got a personal computer in the late 1980s, I entered all my notes, which was a humongous task, in the computer into a spreadsheet, I believe, because at that point I had thousands of observations. And not only did I want my notes, but I wanted to include coordinates and magnitude and sizes and all kinds of other information about the objects. Sometimes those weren't easily available. I guess one advantage I did have over a lot of amateurs in the pre-internet age, though, is was a grad student at UC Berkeley and lived close to UC Berkeley. And so I had access to the astronomy department. And oh boy, in the astronomy department, besides all of the catalogs that were not generally available to amateurs and certainly weren't digitized unless they were available perhaps on microfiche. I had access to the sky surveys, the Palomar Sky Survey, the ESO Sky Survey, and all that. And I spent many, many hours in the reading room in the graduate astronomy library before the internet age. So let me just mention a little bit more about getting started. I basically got into astronomy in the mid to late 1970s and found a 16 millimeter refractor that was sitting in my girlfriend's father's garage gathering dust, and I borrowed that for a year. And after that, I got my sort of first real telescope, which is a 6-inch and 6-inch Edmund reflector. And I've had a variety of telescopes, none of them homemade, an 8-inch, I'll probably forget one of them, but a 10-inch, a 13.1-inch, that was an Odyssey, one, a 17.5-inch, that was a Odyssey 2. Those were the first two large Dobsonians that were generally available for purchase, an 18-inch and a 24-inch. And as a telescope size grew, I was kind of interested in observing always whatever was out there at the edge of visibility in those telescopes. And that necessitated finding a lot of observing projects. Now, once you get beyond the Messier objects, and I guess maybe go to the Herschel 400, well, there are plenty of observing programs from the Astronomical League, but I always kind of liked making my own observing projects. And fortunately, with the larger telescopes and particularly nebula filters that came on the market in the early 1980s, that was just a dream come true. So let me just show you, let's see. This is my current telescope. And I think Howard maybe had a shot at the Golden State Star Party. This is my 24-inch before a lot of people have arrived. Usually Howard is set up next to me. And you can see people set up with their campers or trailers nearby. And I'm getting ready for a nighttime of observing. So what observing projects are we talking about? Well, I'll try to give you sort of a variety of projects that I've taken to heart and will go through at a star party, pick one or two projects and work on them at a particular star party. I think Howard certainly also mentioned Jimmy's telescope, and we've both spent a lot of time observing with him. Here's another view of that telescope, and I'm up on the ladder. You can get a sense of it above the walls of the observatory. It's a roll-off roof observatory. You can already see I'm getting up towards the top of the ladder, and the telescope's probably not pointed at more than 40 degrees. So once you get up above 60 degrees, I'm on the top step of that ladder. So when I talk about recording observations, Howard is usually sitting at the table next to me. He's sketching, and I'm taking notes. As he mentioned, he usually comes down from the ladder, starts sketching an object. I go up there and looks through the telescope for a couple of minutes, come down to our table next to sitting. I'll be seated next to him, and I'll start taking notes on the objects. Now, I kind of pulled out just a sample of old notes to show you I do keep them. And these notes actually are from 1994 at a place in the Sierra foothills called Fiddletown. So they're actually only I guess 30 years old. This was one page from a whole pad I have, and I have all my notes going back throughout the 80s that look something like this. And so this is not through Jimmy's telescope. This is through one of my telescopes, probably my 17.5 inch. And these were taken just seated at a table. I was observing, I'm not even going to talk about this project, but this was observing faint stellar planetaries discovered by Kohoutek and Carl Henneis. And I'll just I don't know if you can read this or not, but because sometimes I will use shorthand or abbreviations, but the first object is K326, and I wrote yes, why? Because I didn't know if it was going to be visible. No one had ever reported an observation. Appears without filter as a very faint 15th magnitude, quote unquote, star. It's not a star, it's a planetary. Identified with a finder chart. What was I using as finder charts? Well, I had printouts using a program that basically plotted the guide star catalog. I don't even think it plotted deep sky objects, just the guide star catalog, and identified it with a finder chart. And I wrote that it was located 1 to 1.5 arc minutes west of a 12.5 magnitude star. And I guess in the guide star catalog, it was called 11.9. And I wrote it had a good contrast gain, blinking with an O3 filter. That's one important thing I always look for with planetary nebulas is what kind of how many magnitudes of contrast gain you might get with the filter. But with the O3 filter, I could tell it was a very small disk, evenly lit. And I wrote it's slightly fainter than a mag 14.8 star. So estimate, I can read my handwriting, I'm sure better than you. I estimated as mag 15.0 to 15.2. And then I boxed first visual sighting. Now, when I don't mean my visual sighting, I'm projecting that it's possible that this was the first ever visual sighting. Why? Well, I don't think that at this point there was very many amateurs that were observing this type of an object. I checked, I wrote below it, I'm reading no JM. That refers to Jack Marling, who like me was interested in observing all these objects, and he hadn't observed it yet. And then I checked with KW, which is Kent Wallace. He was also observing all these, and he reported a negative observation. So I kind of guessed or assumed that it might be the first ever visual observation. Don't know, but if anyone else had observed it previous, they certainly hadn't reported it up to that point or even up to now. And you can see I have notes on a couple of other planetaries, K416, again, a yes, I didn't know what to expect. I didn't pick it up at 220 power without a filter, but once I put in the O3 filter, I wrote once seen with a filter, I can see it for moments even without a filter, taking it out. So these are the kind of notes I took. These were all taken right after observing the telescope. And on that night, I probably took notes like this on 30 or 40 objects throughout the night. Okay, now this was 1994. So at that point, I did have a computer for a number of years, and I was organized and keeping my notes electronically entered. So after I got home, I probably would verify the observation and enter it in the computer. Okay. I thought I actually added this slide after I saw Howard's presentation because this has us both, not at the night he talked about with Ron Buddha, but Howard and I a few years earlier basically had a night on the 82-inch that was just us two and the telescope operator. And the reason was because there was a public viewing for employees earlier in the night. And that ended around 11 or 11 o'clock, maybe 11:15 or so. And the telescope operator, who was a friend we both knew, gave us a phone call and said, "Why don't you come up? There's nobody using the telescope, it's yours." So we had quite a good time. This photo actually was not taken like during the daytime, but was taken early in the morning. It was totally dark, but we turned the lights on inside the observatory to take the photo. You can kind of see I'm still wearing, we're still wearing our nighttime jackets, and I have a cap on. Okay. So let me go through some observing projects now that I've participated in and have spent a lot of time on. And just like Howard, my observing projects and notes generally have translated into Sky and Tel articles, a few of them in other magazines, some prior to Sky and Tel, like Deep Sky magazine, and some other ones like Astronomy magazine. But Able Planetaries was an article I wrote in Sky and Tel. And this is a photo of George Able. George worked on the famous Palomar Sky Survey when it took place in the early 1950s. He was only a grad student at Caltech at the time that photo was taken, and he was responsible. One of the, I think, two assistants was responsible for taking images and also examining the plates afterwards to see if they were in good condition, good shape, didn't include any streaks or perhaps any meteors went through the field, that type of thing, so that they would have to be redone. And in 1955, he published a list of 73 planetaries. He recorded these as he was examining the field. He started taking notes on them as he was looking at the plates. He was really the first ones to look at, one of the first people to look at the plates, if not the first. And He made a second catalog in 1966 that included 86 planetaries known as Able 1 through Able 86. And a lot of these are very large, highly evolved planetaries with low surface brightness. Now, and that's the key why they weren't found earlier visually. They had been missed by the Herschels and others who were observing generally with higher power, small fields of view, and they had low surface brightness. The key was in 1980, the first O3 filter came out. Maybe even there was, I think, another filter, Daystar 300, that came out even a little earlier, 79 or 78. But Lumicon started manufacturing O3 filters, and that really changed the game as far as observing able planetary nebula. So here's just a couple of examples. This is one of the brighter able planetaries, Able 39 in Hercules. That's a 3 arc minute, they're pretty large size for a planetary, a perfect spherical bubble, about 5,500 light years away, with a mag 15.7 central star. You can also see it has a limb brightening. That doesn't really mean three-dimensionally it's brighter on the edge. We're looking at it as it projected on the sky. So as we look at it, we're looking through thicker material on the edge, and that's why it appears brighter. This object is visible with an O3 filter, even in an 8-inch, and it's visible unfiltered in an 18-inch. I thought you might like to see some of my notes. I can go through these slowly or quickly. I've taken notes on Able 39 8 times. They're kept all in my, well, it's actually a database, and I'm just showing you 4 of them. This one goes back to 1985. I think this was my second observation of it. And again, I didn't enter the observation until later. I don't know. So my notes, this was again, my notes weren't that sophisticated back in 1985. I just simply called it faint, fairly large, round. But I did note I could hold it steadily with averted vision using an O3 filter. And I also checked it with a different filter, a Daystar 300 filter. It's not available nowadays, but it's basically a narrowband filter similar to a UHC filter. Then I observed it, well, not the second time, but I observed it another time in 1998 with my 17.5-inch. And this time it was visible continuously with direct vision. And I could tell now it was slightly brighter along the eastern edge of the planetary, and it was visible unfiltered at 100x. And I also noted some stars were superimposed. 18-inch, I still observed, even not much difference in aperture, but I still observed it again because maybe the conditions were slightly better. I was observing at a darker site. Whatever the case was, this time I was able to note that there was a couple of slightly brighter arc segments when I let the planetary drift through the field. Again, all these notes were taken directly after the observation, not when I got home, kind of like Howard might do in terms of finishing a sketch. Of course, I used abbreviations when I was taking notes, and I just expanded those when I got home. Then here's an observation with my current scope with my 24-inch, which I've had for a while. You can see the observation was made on July 7th, 2013. Now I noted the 15 or 15.5 magnitude central star, which should have been visible in my 18 or 17.5 inch. I'm not sure why it wasn't. I have a feeling it's because I did not use, I didn't look at the planetary without a filter at high enough power to see the central star. And I also could tell with using 125x with a UHC filter that the planetary was clearly annular. And I also noted there was also a faint galaxy not far off, 12 arc minutes to the east-northeast. So this is an example of 4 observations that I've made. Seems a little ridiculous. Not that many people would observe one object 8 times, perhaps, though this was the first observation, or the second one was in 1985. So what, we're talking about over a 40-year period. So it's not 8 times over 40 years. I'm not observing it that often. Here's another kind of cool planetary, really cool, Able 70, which is, again, relatively bright. What makes this object pretty unique is there's a background galaxy. That little streak on the top of the image is a background galaxy shining through the planetary at a distance, from a distance of 250 million light years. In other words, it's 10,000 times as distant as Able 70. What an amazing depth of field. Think about that. You're looking at 2 objects on top of each other, 10,000 times difference in distance from us. It's also a very rare central star that is barium-rich binary. The white dwarf, which is ionized the shell of the planetary, when it was in the AGB phase, asymptotic giant branch phase, it polluted the main sequence star with heavy elements, including barium. I think there's only a couple of central stars of planetaries where that's the case. And there is a weak ring visually. Sometimes I've only seen, and some scopes may just show the brightening at the edge of the ring, and it looks like a diamond ring in that case. Again, here's 3 examples of notes. I wanted to do one or a couple of notes with a 14.5 inch. So this is actually from 2021, more recently. I picked it up unfiltered, but then I looked with an 03 filter at 87x and 140, and it was visible continuously as a nice disk. I couldn't really see the galaxy as a real galaxy extended out beyond the edge of the planetary, but I could see the north edge was brighter due to the galaxy. With my 17.5, I'm going back to 2001. Now the galaxy again was visible as a brighter knot, but if I would look carefully, I could see this, I'm reading here, this enhancement is elongated, west-northwest, east-southeast, perhaps 15 seconds by 8 seconds. How did I know which way it was elongated? Very simply, the telescope was drifting through my field of view, so it was very obvious which way west was, and west-northwest was just meant it was tilted a little bit down, and so that was just an estimate. I also noted a couple of nearby stars, and that was about it. With my 24-inch, now the planetary I could tell was had a darker center and a brighter rim, so it looked annular. The galaxy was an obvious brighter streak, and I really looked like a galaxy. And did I see anything else? Well, using 375 power now, the galaxy actually dominated the planetary at a high enough, this is unfiltered. Now the galaxy itself was the first thing, or the main thing I noticed. The planetary itself at that a little higher power the surface brightness started decreasing, and the galaxy was still small enough, high surface brightness enough to actually be a little bit more prominent. By the way, let me just mention again, this one, I see I took notes. I looked beforehand to see how many times I had observed it when I copied these notes. And I have observations 11 different times for Abel 70. Here's George Abel a little bit older, as you can tell. And this is when he was at UCLA. After finishing the pause, he got a position there. And he became a professor at UCLA. In fact, he was head of the astronomy department when I was a student at UCLA in the late 1960s. He wrote his PhD dissertation on the distribution of rich galaxy clusters. And prior to the Palomar Sky Survey, there was really only a few dozen rich clusters that were known. The Coma Berenices galaxy cluster, for example, the Hercules galaxy cluster. And there was a few more distant clusters that were known, but only a few dozen were known up until that point. But the Palomar Sky Survey just revealed thousands of galaxy clusters. And he produced a 1958 paper, a study on 2,712 rich galaxy clusters that he cataloged on the Palomar Sky Survey. And he also determined their size, how many galaxies, how rich they were, and estimated their distance based on how bright the 10th brightest galaxy in the cluster was. Just want to highlight a couple of Abel galaxy clusters, particularly ones I've written Sky Intel articles about. This one, Howard, I believe, had his own sketch of. And it may be this sketch right here. I think I probably just have a little wider view because I believe Howard's sketch was in the article I wrote on the Hercules galaxy cluster. This is 500 million light years away. Still, it can be really explored with a 10 or 12 inch in that range. Many of the brighter NGC and IC galaxies are visible. It's a little bit of an unusual cluster because there's not one bright central galaxy. I'll show you an image of a cluster later where that's the case. And many can be seen a couple of fields away from this particular Howard sketch. I've logged 36 in an 18-inch, and in Lowry's 48-inch, I've checked off and taken notes in one eyepiece field of 22 members. On the very bottom of that Howard sketch, you'll notice I circled a galaxy, IC 1178, and there's a little smudge just to its lower left. Okay, just at the bottom of the screen inside the yellow circle. Well, the little smudge next to IC 1178 happens to be 1181. And turns out that was one of the galaxies that we looked at together with Ron Buddha when he wanted to sketch some members of the Hercules galaxy cluster. So I thought I would show my notes here. The 17.5, I just called it faint. I know that's a pretty vague term, but faint, small, round, bright core. Sometimes that's all you can see, particularly on these Able galaxy clusters. I did see that it was a close pair, though. In my 24-inch, it was a little brighter, of course, and it was sharply concentrated, meaning there was a very small, high surface brightness core with a much lower surface brightness halo. It's actually an ARP pair. I'll talk about ARP galaxies a little later. There was also a nearby PGC galaxy that was a dim edge on. And I actually took notes, I don't know if Howard knows this, with the 82-inch with Ron. This was on May 6th. And I called it, again, there was a strong concentration with an intensely bright, very small nucleus, a very diffuse outer halo, perhaps tidal debris, because this is an interacting pair, extends north, extending to the diameter to about 45 arc seconds, I estimated. And the companion, IC 1181, which in smaller telescopes, just a dim glow, I could see a faint diffuse tidal tail on the east end that swept to the south, bending slightly west. So anytime I have an opportunity to take notes, I do. Here's that Able 2065 that Howard also talked about. This is the SDSS Sloan Digital Sky Survey image with 400 members. Again, I wrote a Sky Intel article on this cluster. I was so thrilled to observe it because Burnham's, which was one of my first sources of data early on, Burnham's Celestial Handbook, wrote, this is a quote, this cluster it had an image which totally captured my imagination. Unfortunately, he called it far beyond the reach of the usual amateur telescope. And even more recently, the Royal Astronomical Society of Canada handbook calls it perhaps the most difficult object for amateur scopes. Well, it is at a distance of almost 1 billion light years. So based on Burnham's comment, I was thrilled. Oh, I don't know, this is going back 35 years. I was thrilled when I was able to log 6 members, probably the brightest 6 smudges you see in that image, 6 members in my 17.5-inch. And that sort of inspired me to write an article. More recently, I've actually gone up there with an image like this and checked off and taken even small notes at the eyepiece. Scott Harrington asked about this. In this case, I did bring an image up to the eyepiece and checked off because I wanted to make sure I was seeing the actual galaxies that I was checking. 43 of them I checked off in one single field in the 48-inch. There's been a lot of other catalogs that have been based on the Palomar Sky Survey, the first Palomar Sky Survey. One is Able's Palomar globulars, which were 15 globulars found by Albert Wilson and himself, another Caltech astronomer, on the Palomar Sky Survey, though only 13 of them are actually new because 2 of them had been discovered previously, one by William Herschel. And then in the late 1960s, an Armenian astronomer, that's who's in this image here, Terzan discovered 11 globular clusters on red sensitive plates, and they had been previously missed because they were highly reddened due to dust in the plane of the Milky Way. In fact, this was another article on the Sagittarius dwarf galaxy that I wrote. 2 of those Terzon galaxy, I'm sorry, globulars are were captured or deposited from the Sagittarius dwarf galaxy, which is currently merging with the Milky Way. Here's one example. This is Palomar 8, which George Abel found in the early 1950s. And looks kind of dim, but in an 18-inch, perhaps even smaller telescope, I've resolved a dozen stars in that globular, taken notes on it. And I find this globular, one reason I picked this globular was I've had access to E.E. Barnard's logbooks at Lick Observatory in San Jose and gone through all his logbooks carefully and found that he actually made a visual discovery of this planetary in 1889 with a 12-inch refractor. Unfortunately, and even said it was likely a globular cluster. This is with a 12-inch. Unfortunately, he never published the discovery. Why? Well, his main interests at that point were observing comets and planets, and a lot of his discoveries, dozens of his discoveries, he never published, unfortunately. Again, that turned into a Sky and Tel article on Barnard's unknown discoveries. Here's a Terzon globular. This is certainly not the way it looks visually in any telescope. That's a Hubble image. This is a highly reddened globular looking towards the center of the Milky Way. I think it's projected just a couple of degrees from the actual center of the Milky Way. And it's only it's over 20,000 light years from us. So you're looking through a lot of dust in the direction of the center. And it's only a couple of thousand light years from the actual core of the Milky Way. And this is visible in an 18-inch. It's a tough object, and it is partially resolvable in the 48-inch. Let's go on to a few other projects. Some of them are for large telescopes, some for smaller telescopes. I should mention, even with whether we're talking about Terzon globulars or ring galaxies, you're often not going to, you're never going to see the image, some of these images on Hubble, of course, on taken with the Hubble or the Sloan Digital Sky Survey. Sometimes often you're just pleased just to glimpse the object at all, and that's all you can do. Still, that's a lot of fun to track it down, and knowing what the object is, knowing what it's all about, that's what makes it satisfying. So there's various types of rings. Just there's collisional rings, polar rings, HOAG rings, empty rings. Most of them are targets for large telescopes. Mayall's object, that's an ARP, I'll talk about that in a little while. That's a collisional ring. You can see one galaxy passing right through the center of another one. And the middle one is a empty ring, Sebenzwicki 466. This probably is like Mayall's object, but at a later stage where the galaxy has moved away already. And the last one is a polar ring galaxy. You can kind of see a ring going around it vertically that almost looks like an edge on Saturn. And that actually, it's funny because Saturn right now the rings look edge on, almost. This is a galaxy in Centaurus. Unfortunately, it's too far south to view from the US, the continental US. But it's a beautiful object. VV are Boris Vorontsov-Elyuminov was a Russian astronomer. He used the POS to make a catalog of 350 interacting galaxies. Many of these are deformed pairs, and that inspired Halton Arp to come up with his catalog of peculiar galaxies. Here's an example of one of his interacting galaxies, the Taffy galaxies. These are UGC galaxies. 12914, that's the one on the right, 12915 on the left. They collided about 20 million years ago, and they're still connected by a gas bridge that resembles strands of taffy, particularly on radio maps, and that's how it got its name. The spiral arms are visible in a larger telescope. In my 18 and 24, you can just sort of see the beginnings of them. In the even larger telescopes, I have some notes where comparing 3 different apertures, 17, 24, and 48. With my 24-inch, I could just see a spiral arm attached to the galaxy that's on the right, that's hooking towards the one on the left. And also the one on the left had a short extension or arm. But in the 48-inch, the arms were bright and curving and nearly attached to each other. Almost in an embrace, I wrote, but they didn't quite connect. This was observed in 2013. Here's another coalescing pair. Again, observed it even in an 8-inch. This was in 2019. Just to show you, not all of these require a large aperture. 17.5 and 24. With an 8-inch, I just saw a single ghostly patch. With the larger apertures, I could see individual galaxies were resolved, even though they're pretty close together, 16 arc seconds. And so they need higher power to resolve them. Sometimes I'll record the SQM readings, the surface brightness of the sky in magnitudes per square arc second. And with a 24-inch, it was 21.72 at the time. ARP's galaxy, a lot of amateurs are familiar with ARP and his Atlas of Peculiar Galaxy. That's 338 individual galaxies and groups. So there's a lot in there to keep you busy. I love observing ARPs. Some of them, they're faint and you just want to detect them. Other ones, they're challenging to detect structure. So lots of fun. This is an example. ARP 81, this is an NGC. In fact, it's 2 NGCs. What makes it really special is it discovered by a 14-year-old, the son of Lewis Swift, Edward Swift, who observed with his father in 1885. And it has a one-sided on the east tidal tail, which is pretty unusual. Those 2 smashed blobs on top of each other are the 2 galaxies. And there's kind of a blue knot right in between those 2 smashed blobs. That's a superstar cluster. And all this structure is visible in a 48-inch. Here's another one that I wrote about when I was writing about galaxies, colliding galaxies in a Sky and Tell article, the Penguin and Egg, which is ARP 142. And in this case, you can see the penguin, that blue galaxy, kind of above the oval, the egg, and the blue galaxy is a distorted spiral that's overlaid with silhouetted dust lanes. Quite an amazing image with blue streaming newly formed stars, star clusters in the neck of the penguin. Here's one last ARP, which is the antennae galaxy. And this is a mashup of two gas-rich spirals. You can see these are little dots. This is Howard's sketch, which he lent me through to use, I believe, in the article. And he made this with a 90-inch Bach telescope. And all those little dots are H2 star-forming regions. And many of those are visible in a large telescope. I've counted 15 of them in the 48-inch. And of course, that's observing knots and features inside galaxies. That's a whole nother topic. I just want to maybe do one more project. I could keep going on, and I'll also want to show you some of my notes. So I'm going to stop on this. This is Igor Karanchentsev. He and Valentina, his wife, in late 1970s, came up with a catalog based on the POS of 84 isolated triplets. So they're not rich groups, they're just trios. And all the galaxies are 16th magnitude photographic. That means they're probably 15th magnitude visual or brighter. And he also came up with a separate catalog of southern galaxies, 76 additional triplets. And I've gone through every one of those 84 as an observing project, and wrote a Sky and Tel article on them. This is one example. This is KTG, Karatchentsev triplet group 29. These three galaxies, that's a image from the Sloan Digital Sky Survey. Those are crammed into, that's an interacting triplet crammed into 1.3 arc minutes, kind of the size of a small galaxy, all three of them, and needed 375 power to resolve that close pair. So I think what I'm going to do, I can keep going on. This is flat galaxies. That was another article. But I think what I'd like to do, since I'm running a little long here, is I think I want to see if I can go over and show you my observing. Let's see if I can do this. Let me see if I can. I'm going to change my sharing to my notes for a minute. Okay. So where do I keep my notes? So you can see here, I may have, seems like changing this may have frozen my video, but that's okay. You can hear me, Howard, or not?
Oh yeah, we can hear you.
Okay, I'm just going to continue and just finish this.
Okay.
So you can see my note. This, I know you can't see this. It's too small. It's filling my screen right now, which is a fairly large monitor. This right here, which sort of looks like a spreadsheet, are notes on literally 20. I'm reading this on the bottom here. 23,819 objects that I've observed. Okay, these are all my notes. Now, within a particular note here, within a particular object here, I may have observed that object multiple times. So I don't know if you may not be able to see this, but I just opened up a little window in my, looks like, again, a spreadsheet. It's really a database. And I have notes for that object from 1997, 2005, 2013, 2014. Okay. Now, so what can I do with this? I have multiple fields that I keep track of. I have the name of the object, the type of the object, the aliases of the object, type of object, if it's a galaxy or whatever, RA deck, size, position angle, magnitude, surface brightness, constellation, dates that I observed it, NGC description, William Herschel designation, John Herschel designation, date it was discovered, historical information. This object right here, I don't know if I can pick a better one here, but I have information about when it was discovered, who discovered it, etc., including their original description. So this, I opened up a window that has an object William Herschel discovered, and I have his original discovery notes. And then I have, of course, all of my notes, like I said. And finally, in addition, if I want to select a certain class of objects, for example, I might want to select all my ARPs. So I can very easily select either name contains ARP or aliases contain ARP. And I'll just, now I have on this, well, you can't see all of them. I'd have to scroll up and down, but I have 676 objects that have ARP designations on the screen right now. They're all sorted by RA, but perhaps I want to sort them by constellation. Well, I just select the field that's the constellation field and go here, and I simply now can, you can kind of see I've got them all. Andromeda's at the top, Aquarius. I've now got them sorted by constellation. So it's very easy for me to find things, and I can print out reports very easily of the objects, specific objects in any format I want, within the database. So I think I'm going to stop at this point. I think I've actually gone right up to 7 o'clock. And I don't know if at this point, if people want to log out. I understand if anyone wants to ask any questions at this point, I'd be very willing to answer questions. I may want to see if I can take a second and unfreeze my video, Howard.
Sure.
Let me just see what happens here. Let me go back and let me see if okay, am I back on?
Yes, yeah, we can see you now.
Okay, so let me stop the share, I guess.
Okay.
Can I do that?
Yep, I have the first question too.
Okay.
Actually, more of a request. When we observe together at Jimmy's on the 48-inch, you always have this 3-ring binder. Where you
Right.
have all these printouts that have black on white images of all different kinds of objects. And most of them have notes that you've written on from previous observations. Could you talk about how you go about organizing that type of thing before you go out to observe?
Well, it's funny. With Jimmy, I have actually a large, I don't know what it is, a 3-inch binder filled with images and charts just for the 48-inch, because there's things I'm going to look for in his telescope, of course, that I know I'm not going to see either in my 14.5-inch or 18-inch or 24-inch. And so that one notebook that I may bring is just dedicated to him. Now, depending on what season we go there, what month, I'll take out a subset of those charts and put them in a smaller binder So I'm not taking the real large one, it won't fit in my backpack very easily. But sometimes there are objects that I've observed before. I think that's what you're referring to, either in his telescope or perhaps my telescope. And afterwards, I don't have a laptop there. Neither one of us. Jimmy has his laptop, but we're not looking at images as you sketch it or I take notes. But when I go home, I'll compare my notes with an image on the screen, and I will see if there's any features that I perhaps missed when I observed it, a few days earlier at his house. Sometimes that might just be the next day when we're sitting around. I'll look at an image and say, whoa, there's a little knot up here. I didn't realize that I missed. And so I'll put a little circle or arrow at that particular feature, and then I'll want to go back and observe that object again, just to look for that one or two specific features, even though I've looked at the object before. Not sure if that answers your question a little bit, but
Yeah, but it does. But what I was really getting at was, how do you decide which objects you're going to go to that level of detail on?
well, God, as you probably, it's not too hard, because as you know, with his telescope, I'd probably say any galaxy brighter than about 12th magnitude or 13th magnitude is going to show spiral structure and knots, etc. But basically, we seem to all love observing very similar objects, ARP galaxies that have unusual morphology, sometimes are thin edge-on galaxies and ring galaxies. And I particularly like observing galaxy groups. So I'm always trying to find some really faint Hickson group. I've tried observing all of them with my 18 and 24-inch Hickson compact groups, but I might have only seen one or two members in the 18 or 24-inch, and there's 5 of them that Hickson with Hickson designations. I didn't get to Hickson, which actually Hickson compact groups was actually the first article I wrote for Sky and Tel back in, I think, 1999. And I want to try to observe every single member of every single Hickson group, and that's the scope to do it in. So that's what I'm sometimes doing when I'm going back to a Hickson.
Okay, so I have another question. I know there are others. I'm just going to ask it because I'm here. You write some unbelievably detailed observing reports that goes on the TAC email list, and that end up on the Adventures in Deep Space website.
Right. And that's where I have all my notes also.
Yes, that looks like an enormous amount of time and work goes into those.
Fortunately, like you, I'm retired.
Yeah, that helps.
Yeah.
Well, they're all very, very wonderful. So are there questions here? Yes, there is a question, Rob.
Yeah, I might have just gotten the answer, which was what's going to become of the Gottlieb database? What's your future plans for it? And I guess it exists online, right?
Well, part of it exists online. Well, I think I showed you, I have notes. A little bit of an exaggeration. I do have notes on 23,000 objects in my database. I think a little bit of an exaggeration because from home, I have some more pedestrian projects like observing double stars. And so I have that 23,000, I think, includes something like 3,000 double or multiple stars. And I'm not really into variables that much. So there's maybe 20,000 deep sky objects that I have notes on. I'm not sure exactly. I might have online something like 12 to 14,000 objects. I'd have to look. So they're not all online, but I am planning to put them all online. I could. I have to just sort of figure out how to organize them the best. But I think the next time I do an update, which should be pretty soon, I think I'll put some new classes of objects, whether it's planetary nebulae, emission nebulae, sharpless nebulae, dark nebulae, something I haven't done before. So I do plan to keep increasing that, my notes online.
Okay. Yeah, and are you getting more into sharpless objects because of night vision device?
Yes, but I've also, perhaps like you, I do have notes on quite a few sharpless, when we viewed them, with filters, with an O3 filter or UHC filter. So now I sort of have notes on quite a few of them with both, actually, which is kind of interesting. But yeah, that is the case. I'm doing as Howard kind of knows, besides the double stars, I'm kind of doing night vision observing at home at my light polluted backyard, where there's really nothing much I can do in terms of deep sky observing.
Okay, so we have a couple of questions on chat.
Yeah.
Uh, Do you have a red flashlight you prefer? And do you hold it in your mouth or set it on the page? Take it you have your pad sitting on a table next to you.
Okay. Red flashlights. The bane of amateur astronomers. Either they break or they're too bright. I don't, whatever red flashlight I've had, I usually have found that I needed to dim it by diffusing the light somewhat, either covering it with red cellophane or inside, or somehow covering it, or diffusing it so that it didn't create such a concentrated beam. That, I guess, can be done with any flashlight. So I don't really I'm always in search of a good flashlight. Scott, if you have one you found, I'd be very interested in hearing about it.
I think we all would.
Do I hold it in my mouth or set it on the table on the page? I guess you're referring to when I'm writing up my notes. I'm not writing on a computer. I'm just writing them on a notebook, my notes on a piece of paper, on a notebook pad generally, though sometimes on an actual chart that I've printed out, like a megastar chart, or even sometimes an image. And well, I don't stick it in my mouth. No, I have used. I'll either hold it, or I have used lamps that I've red lamps that I've table lamps that have been attached to an observing table also, that were very dim. Generally, I just hold it in my hand as I'm taking notes and just dim the flashlight as much as I can. Keep it dim. It's usually pretty dim. I'm usually complaining about other people near me that at star parties whose flashlight is too bright. But that is an important consideration. As far as recording SQML readings, yes, I generally nowadays try to take, if I remember, try to record, and Howard does also, record the SQML readings. I don't do it, well, a couple of times during the night, but not at every object. Howard does it more regularly. I did try a voice recorder a little bit, and I just found it too complicated to try to transcribe the voice recording later into notes, and I stopped doing it after a few times. Maybe if I'd stuck with it, I would have found that worked better, but no, generally I don't do that.
Any more questions here?
Well, I have a comment.
Okay, we have a comment.
Okay,
Incredible amount of work that you've done.
Okay, did you hear
Oh.
that?
yeah, well, thank you very much.
It is an incredible amount.
It does take somewhat of a, let's put it this way, an obsession that some of us have, an obsessive commitment to this hobby, and I've definitely had that bug for over 45 years.
Well, it's if nothing else, it's a feat of organization.
Yeah,
I think if you looked at most people's stash of lifetime notes that they've taken for their observations, it would nothing would compare, at least that I've ever heard of.
well, thank you, Howard.
Yeah, but yeah, I've thought about doing that every so often, but my system works just fine for what I need. But yeah, it's yeah. What was it, 23,000 now?
Yeah.
Yeah. And have you seen all the ICs now at this point?
I have just about completed the IC1. Now,
I see.
why that's, and quite a bit of the IC2. But what I have tried why the IC1 is significant, there's two different index catalogs, 1 and 2. 1 only had about little more than 1,500 objects in it. But what really appealed to me is every one of them, with maybe about half a dozen or so exceptions, or maybe a dozen exceptions, a little more than that, were discovered visually. So they were discovered really before the advent or the popular use of photography. The surveys that were done at Harvard College, say in the north and in the south in Peru. That really appealed to me, that they were all found visually. So I have observed all the ones in the IC1. That's what I've completed. And those are all available online.
Okay, very good. So impressive. Okay, any other questions here or online? No, but thank you so much, Steve. Great
Thanks,
stuff.
Howard. Thanks for hosting.
Okay, so that is a wrap for this evening. And we'll pick up the action again tomorrow morning. I think you all have the agenda, so I hope to see all of, or at least most of you again tomorrow. And we have a nice crowd here in person. And right now we're going to go start our little barbecue dinner, which is always a nice bonus. And let me tell you, it's a really good barbecue. No matter how far away you live from Portland, it's worth flying in just for the barbecue. So anyway, so thank you so much. Thanks to everyone for watching, and see you all tomorrow.
Okay.
All right. Good night, everybody.